Hi guys, this is Math 148 and we're jumping right in on section 9.1. I am your instructor, Kate Wharton. Welcome to the class. Let's jump on in. So I'm looking at your homework and this is on page 553, limits. I woke up and said, let's do some limits this morning. So this is question number 21 and this question reads, I just kind of skipped ahead to 21. Let's find the limit as x goes to 3 of x squared minus 9 all divided by x minus 3. So what's a little strange about this problem is if we just plug in 3, x equals 3 right there, then we get, 3 squared minus 9 all divided by 3 minus 3, right? And that's 0. And 0. Okay, normally dividing by 0 is not a good idea. It's a no-no because it's undefined. But because we're doing limits, this 0 over 0 is a good thing. It means you can take the limit by sort of reducing the rational problem. I'm looking, this is on page 548. They call this the type 1 limit function. And your book has a lot of names for these things. I'm never going to say, is this a type 1 or type 2 limit? I just am interested in you being able to solve the problem. So, one thing you could do if you're solving this problem, you could say, well, I plugged in 3 up here and I got 0 and 0, but that's okay because 0 and 0 tells you you can keep going. It's okay. You can keep going to find the limit. Keep going, I say. So what you're going to do when you get this 0, 0 situation, you're going to factor. So you think, well, x squared minus 9, that's our fancy pants, right? Perfect square. X minus 3, except I can't write it. And then x minus 3 on the bottom. You didn't have to factor that one. Technically, to be perfectly mathematical, I should write, it's not equal to this function, it's equal to the limit of this. And now we can cancel. You just get to cancel. How easy is that? Excellent. That means that's the limit of x goes to 3 of x plus 3, and now we have a polynomial. A polynomial function, and this is, if you look on page 5, oops, I ran out of space, 547, there's the rule that says when you have a polynomial function and you want to find the limit, you can just take this x value and plug it in. So now we can just take x equals 3 and plug it in here, and we can say this limit right here, all this equals, plug in 3, 3 plus 3 equals 6. Ta-da! So this big mess, the limit of all this stuff equals 6. So on a test to show your work, what I would like to see is this stage here, the factoring stage, and then maybe you can go to 3 plus 3 and then 6, like that. So your work will be a lot less than my work. So I'm also going to go over question number 23, but let me get a new page. The section 9.1, question number 23, and that's still on page 553. So in this problem, we have, you're supposed to find the limit as x goes to 7 of x squared minus 8x plus 7 all divided by x squared minus 6x minus 7. Some of you are going to see the factoring right away and you're just going to want to run with the factoring. And you're welcome to do that. I don't really care if you run with the factoring. But let's say you don't want to bother trying to factor, so you want to test first. So we're going to do our little test to see if factoring is going to be worth our time. So you plug in x equals 7, and the book doesn't define this as a test. They just are identifying the different types of limits. So on the bottom, you would get 7 squared minus 6 times 7 minus 7. And on the top, you'd get 7 squared minus 8 times 7 plus 7, which equals, wait for it, equals 0 divided by 0. Wanted to check to make sure. I often make little calculation mistakes and I try not to do it in videos. So once again, we find ourselves in this 0 divided by 0 situation, which basically means that we can continue on and factor. Continue and factor. If you had gotten a 1 over 0, then you'd have to stop because the limit wouldn't exist. So now we factor. So this is the limit as x goes to 7, and we're back to a factoring problem, which is easy for some people. So you say, well, there's a 7, 7's perfect, it's just 7 times 1, and that's a minus, so I'm going to go x minus 7, x minus 1. This one you have a minus 7 and a minus 6, so I know it's going to have to be minus 7, so I can get that middle piece, and then x plus 1. This is factoring. Thank you, algebra. So the x minus 7's cancel, so this is now the limit as x goes to 7 of x minus 1 all divided by x plus 1. And now we have this rational equation situation. And again, this is a little rule. If you were wondering what that box, this is what your book calls the type 1. That was the type 1 thing from page 548. Page, that's supposed to say page. And right here, this is the rational functions. And that is on page 547. They give you the rule about rational functions. So we can essentially take this 7 and plug it in here and here. That's kind of the gist of the rule of rational functions. So that limit equals 7 minus 1 all divided by 7 plus 1, which is 6 divided by 8, which is 3/4. Ta-da! Yay! 3/4. So on a test, you do not need to write all this stuff. You'd want to write this step, maybe this step, and something like that step. So you could just reduce it a little bit, but I want to have a sense of, oh, I see what you did. If you just write 3/4, it's a little bit suspect. Not hyper suspect, just a little bit me wondering where you got that number. So, in case you're thinking, what does all this mean? Limit as x goes to 7 of this giant algebraic equation is 3/4. How does that even, what is that saying? Here's what it's saying. So, this is a online graphing program that I like fairly well. It's myhrw.com, and it's free, so you can go in there and type stuff. You're welcome to use your calculator too, but sometimes the calculator is, can be a little tricky. So if you want to use this one, I don't care. You can use whichever one you like. Just giving you some options, people. Everybody likes options. So you can type in this equation and hit graph. Let's see if it'll do it. Come on, baby. Ta-da! So what this is saying, the limit as x goes to 7, let's go back to our graph. Here's 7. So the limit as this graph is going towards 7, this function right here is hitting the line 3/4. It's approaching 3/4. That's all it's saying. It's saying this graph, as you come along and you're going towards 7, it hits 3/4. And if you went that way, it's also going 3/4. So that's all. That's all limits are talking about. It's kind of what number is the graph going towards as you move along the x-axis. So I will do more problems in the next video.